try to implement the physics of elastic collisions. And to start, I created a very simple simulation of two planets colliding, just to see what would happen without changing any of the original physics. And basically, the planets, as you can see, disappear unexpectedly when they collide. And I think this suggests that basically the physics breaks down. And I don't know exactly why they disappeared. That really doesn't make any sense to me. I think that maybe what happens is that they go out of the frame, um, but I'm not really sure about why that is. The first thing I did was basically look for an equation for elastic collisions, and I started with the one-dimensional Newtonian one, but I realized that I needed a two-dimensional Newtonian one, and there's two versions of that one. There's either you can use the one that uses angles or the one that uses vectors. And I started with the angle one, but I couldn't figure out how to calculate the contact angle. I think I had an idea, but I didn't know if it was going to work, so I just switched to the vector one. And to be able to work with the vector one, I created a very simple vector class. Only works for two-dimensional vectors, and it could perform the operations needed for these equations to work, which are vector subtraction, the inner products, and scalar multiplication of vectors. And so I got that all to work, and I created a file with some tests to make sure that everything was working. And I ran into the problem that if two planets are precisely in the same position, then this inner product would be the inner product of a vector with the zero vector, which to my understanding is always zero. And I don't think that's correct. That doesn't make any sense to me. So what I ended up doing is I created a fake radius. I assigned a fake radius to all of the planets just to ignore the case when just to avoid the case of two planets ever being precisely in the same position. And once I did that, it seemed to work. So after I got the equation to output numbers that made some sense, basically the last part was figuring out how to relate one thing that I forgot to mention. This equation is for the change in velocity due to the elastic collision. Once you have the change in velocity, you can calculate the acceleration um, over some change in time. And once you have that, you can calculate a force due to the elastic collision for the two planets. And once I had the force for due to the elastic collisions, I had to combine that with the force due to gravity. I couldn't keep them independent. When I was calculating I couldn't just ignore gravity while I calculated the collision. That doesn't make any sense. So what I ended up doing is that while I was calculating the force due to gravity, the net force due to gravity for any planet, I checked to see if there was if the distance between any of the planets was shorter than the diameter of the planet. And if it was, it would mean that there was a collision happening. And if there was a collision happening, I would calculate the force due to that collision and add it to the net force. And that's basically how I went about it. And the only thing I'm very confident in the equation. I think I got the equation to work as it should. But the only thing there's two things that I think are still shaky. The first one is the fake radius, which I already mentioned, and the second one is the changing time due to the collision. That's another thing that I could never figure out. I'm not sure if there's a way, but I couldn't figure out how to calculate how much time the collision would take. So what I ended up doing was just using the change in time provided by the simulation itself. I don't know if that's correct, but it seems to work to some degree. And I can show you the same simulation with the added elastic collision physics. And as you can see, the planets bounce, which is basically what they're supposed to do. And I have a couple more simulations. And this is with the normal physics first. And as you can see, it's completely broken. One planet goes through the other one, and it speeds at a but if I add the elastic equation physics, elastic collision physics, um, you have something that it makes more sense. And I have one final test. One thing that I did notice is that if I messed with the change in time over here, things would just start to break for both the standard provided physics and with the added elastic collision physics. The behavior became very unpredictable. For the with the normal physics, again the object disappears, and if I add the elastic equation physics, um, we should see them bounce. Yep, and that's basically it.